you, Ina. Good afternoon, everyone. I'm Nicholas Johnston. I'm the publisher of Axios. Thanks you so much for joining us here today. We've had a great week of conversations continuing. Super grateful to our partners at Qualcomm for hosting us in Qualcomm House again this year, and so I'm very welcome who's early to the stage. My good fate, I'm going to get it right this time, the President MEA and SVP Government Affairs EMEA, Wasim Trubaji. Wasim, great to see you. Have a seat.
Great to have you. Thank you so much, Nicholas.
So we're like continuing a conversation we started last year about AI. It was so hot, it was so theoretical. And this year it seems the conversation is transitioning a little bit to adoption and implementation. So from your vantage point, like how is that changing the conversation and what you're thinking about, and what are the important things to keep in mind?
So first, thank you for having me, Nicholas. It's always a pleasure to be with you. And it's great to see actually the evolution between concepts and actual practical implementation. So the way we look at AI right now is how to scale it in a sustainable way, in a way that ensures security and privacy. It's a big challenge. But
list of concerns there.
List of concerns. But the beauty about engineering is you find solutions for those. And that's what we are working very hard to address.
So let's take that next step. Okay, we've outlined the problem or the challenge we're facing. Yeah. Start to piece together how to address those challenges.
So the first thing we're doing is to make sure we design semiconductor in a way that allow AI to scale to all the devices you have, whether in the palm of your hand, that's a smartphone, or the PC, or the spatial computing XR devices, automotive, you name it. We call it the edge, in a general term. And we do it in a way that's high performance and low energy consumption way to make sure it is sustainable. The other way we're doing is bringing the AI as close as possible to where the data is created. And that ensures privacy and security. Instead of sending everything back to the cloud, you do it in the palm of your hand. And it ensures also responsiveness and very low latency.
Right, so let's tick through some of the concerns, how it solves it, because I've thought a lot about this. Like on the latency one in particular, I've been frustrated here in the mountains asking AI questions and then losing my cell signal and then not knowing if there are wolves in the Alps, as we talked about the other way. You bring that onto the device, how do you solve for that?
Yeah, so the first thing you could do, and actually this is a conversation I'm having a lot this week, is that people think about the large language models that's sitting in the cloud, and they would go there and it's evolving there. But more and more we're seeing these large language models being quantized, being smaller, very fine-tuned, and addressing specific use cases to allow to run on your own device. And then what we have done is to integrate all of that in the same silicon. So you have the CPU, everybody knows of the central processing unit, but we create an AI agent, AI neural processor that's sitting in the same place, which runs AI all the time with you. Yeah.
And then when you're not bouncing it back to the big data centers, tell me what that means for power consumption, which is a huge concern for AI.
Yeah, I mean, you have phones in your hands, you have your car, you have your PC. They're all computing. They're all computers. So you have processors actually power sitting there, which we're leveraging. That's really it. And you do it in a way that's super efficient. I'm happy to give you an example, actually.
Okay, well, no, like this is, like, know where we're going with this one. Like, so much conversation about AI is theoretical. It's 6 months away. It's 2 years away. You have something in your pocket that you get to show us?
Yeah, I would love to show you this because, you know, the conversation is always, and I love that. We love talking about what's next, but actually also how you get it real. That's what we do. So yeah, what I brought here is a Qualcomm reference design of a smartphone, right? That's what we do. It's like we design chips that goes into all kinds of devices, and we do reference designs, right? That OEMs, manufacturers would use to produce the actual products that sits in the hands of the people. So this is a reference design with Qualcomm latest chip, right? And you won't see it, but you can see it. It's airplane mode. You see the airplane mode at the top? Yep. Yeah. So what we did is we took a 7 billion parameter model. We quantize it. It's airplane mode, right? And this is just to show the functionality. It's a chat. It's multilingual, right?
So live demo.
Yeah, it's like, help me plan 2 days in Davos. And real time, absolutely. This is day
Without
one.
having to go to the internet, without
This
having to
is
go
no
find the cloud,
internet.
it's
This
in
is
the phone.
completely offline. And you can see it across the board. As I said,
Still going.
it's still going, it's still
Gotta
telling
do
you. And you
that.
can stop it. What's the World Economic Forum? So you can continue the conversation, and it gives you all the data.
Not theory, in practice. And
This
so,
is
like,
in practice. Offline mode, and you can engage with your devices real time, offline.
so that's a fun example, but I
Yeah.
think you've got more here. It's like this is actually deployed. These are things being used in the real world by real customers in real industrial.
That's coming in all devices in 2025. So it's real.
And so I think we've got a video we can show. We're not supposed to show a video, but Wasim showed me this the other day. I said, we're going to figure out a way to put it up on the screen. And so once
Okay.
this pops up, I want you to narrate in real time what we're seeing here and how this on-device stuff is being
Yeah, so this is what you saw here is the capabilities of the chip, right? And it will come into smartphones, etc. But what we did is, as you know, AI will transform all industries. So we worked with Aramco, one of the largest industrial companies, oil and gas, obviously. And the problem statement is how edge AI would transform industrial operation using the capabilities I just described. So you look at a worker in the plant, no internet access. How can I use these capabilities to augment the workers? Reduce maintenance time to go and look at equipment, say, how can I repair it? What happened here? What kind of equipment is that? And you speak with the equipment.
carrying on their
You're
phone
carrying.
as they're
You see it
walking
in the video. You're carrying on the phone, no internet. You know what's this? It's a vertical stabilizer. How can I use it? This is how to use it. How can I, change the valve? It tells you how to, and it's trained on the industrial data. We also have, all about drones. You have drone in a box, but then instead of saying to the drone, hey, go to XY coordinates in a plant, you would say, hey, help me understand, is there something wrong happening in my plant? Yeah, no, everything is okay. I know, I noticed something is happening. So go there, tell me what's going on. You engage with the drone. Same with smart cameras. It changes everything, the way you think about it today.
And it's pushing that that capability down to the device, down to the drone itself. So it's making those decisions.
Yes, so what you see is actually by doing that, is at first you push the intelligence to the device. So the data remain in the device, right? Remain in the device. You don't need to send it back to the cloud. Super highly responsive time, right? So you can engage with all these equipments and you enable actually, the benefits are huge. Reduced downtime for maintenance, increasing productivity, making the worker's life better, improving safety in plants. So I mean, the ROI, the return on investment in these technologies is significant. And this is deployed. It's not like theoretical.
We saw the video. You did it up here. So, I love this real-world explanation. Before we run out of time here, spin it forward. When we're back up here next year, what cool stuff are you going to bring?
I think the way to think about it is that everything is being transformed, right? But something that I think is not well discussed or understood so far is that, you see what I just described? I spoke to my phone, I'm speaking to my drone, I'm speaking to the camera. So the computers or these devices are starting to understand humans and what your intent is. Think about it also what we did with the Meta glasses, where you have cameras here, same lenses, and you have an LLM or a small language model here. The device starts seeing what you see, start hearing what you hear. So it's a huge potential there. What we're saying is that these new capabilities will change the user interface, the way we engage with all these devices. in the cars the same, and we showed it. So it's quite impressive. How much time it will take to get to scale is the question. It's not the if, it's the when right now.
Well, we'll hold you to that. Bring
Yes.
it next year. I hope to see you again on the promenade. Thank you, Wasim.
Thanks so much.
Again.
Thank
Thanks
you.
again
Thank
for
you for
Qualcomm
having
House
me.
for making all of this
Thank
possible.
you.
Thank you all for joining us. Stick around. We have snacks. We have networking, hangout. Thanks for coming.
Thank you.